Ever wondered how AI turns a simple text prompt into a vivid image? It's like magic, but it's actually a mix of math, creativity, and a clever trick with noise. Today, we're diving into a groundbreaking approach that's changing how AI learns to generate images, and it all starts with something you might think is useless: low-quality data. Let's start with the basics. AI image generators, like the ones that turn a futuristic city at sunset into a picture, rely on something called diffusion models. Here's how they work. Imagine starting with a blank canvas full of random noise, like static on a TV. The model then slowly removes that noise, step by step, until it reveals a clear image. But here's the catch. Traditional models need perfect training data, crisp, high-resolution photos. What if we told you that the bad images we usually throw away could actually help? That's where Ambient-o comes in. This new technique flips the script. Instead of filtering out blurry, noisy, or synthetic images, it uses them strategically. How? By adding more noise. Wait, adding noise. Let me explain. Think of it like tuning a radio. If you're trying to hear a distant station, a little static can actually help you pick up the signal better. Similarly, when Ambient-o adds noise to low-quality images, it blurs the line between good and bad data. This helps the model focus on the big picture, like the shape of a cat or the structure of a building, without getting stuck on messy details. But here's the secret sauce. Ambient-o uses two natural properties of images. First, spectral power law decay, which means images have a predictable pattern in their details, like how a forest has trees of varying sizes but follows a general structure. Second, locality. Features in an image are closely tied to their surroundings, like how a cat's ear is connected to its face. By leveraging these, Ambient-o doesn't just tolerate low-quality data. It uses it to teach the model about global patterns and textures. The results? State-of-the-art image quality on benchmarks like ImageNet, with more diverse outputs. Traditional models often sacrifice creativity for clarity, but Ambient-o shows that messy data can lead to richer, more varied results. It's like giving a painter both a masterclass in technique and a bucket of experimental paints. The final artwork is both precise and surprising. Take a blurry photo of a sunset. A traditional model might struggle to recreate it, but Ambient-o adds noise, blending it with cleaner images. The model learns to recognize the essence of a sunset, warm colors, light gradients, without getting bogged down by the blur. The end result: a vibrant, realistic image that feels authentic. The magic here isn't just about data, it's about how the model learns. Researchers used a mathematical rule called Hoeffding's inequality, which basically says, the more data you have, the more reliable your predictions become. It's like getting a clearer view of a mountain range as you collect more data points. Even with noise, the model's internal settings, called parameters, evolve in a predictable way. Think of it as a GPS that adjusts its route when the road is under construction. These rules keep the AI from getting lost. Let's talk numbers. On a dataset called CIFAR10, think of it as a library of 60,000 images of cars, animals, and more. Ambient-o outperformed traditional methods. When images were blurred or compressed, their model achieved a Frachet inception distance, FID, of 5.85, compared to 8.79 for models trained on clean data. Lower FID means better image quality. It's like getting a sharper photo from a blurry original. Imagine training a model to draw cats, but half the photos are fuzzy. Ambient-o is like giving the model a set of rules to guess the details from the noise. It's not perfect, but it's way better than ignoring the bad data. And this isn't just theoretical. Applications range from medical imaging, where low-quality scans are common, to AI art, where imperfections can spark creativity. So why does this matter? It means AI can train faster, use more data, and create more creative images. Plus, it's a win for real-world applications where data isn't always perfect, like historical archives, where old photos are often degraded, or autonomous vehicles, which must interpret messy sensor data. Next time you see an AI-generated image, remember, it might have been shaped by the bad photos we never thought to use. Thanks for watching, stay curious, and keep exploring the future of AI.